ordinary differential equation, which is second order ODE. So far, what we have done is only first order ODE. So today's topic is going to talk. I'm going to talk about second order ODE. Second order ODE. Okay. Why not we look at our question paper for the project? Question paper for the project, which is this one. Okay, let me share that thing here. Okay, this is our project number 2. Again, if you read the header here, it says this is a 2-member group project. While discussion with other students is encouraged, all work submitted for credit, however, must be your own. Any evidence of plagiarism or any other form of scholastic dishonesty will be ground for a failing grade in for this course. So, okay, so let me be very clear about this statement here. 2-member group, 2-member group, which means both of you must do the project. Okay, I found out in project number 1, okay, there's been an arrangement between the 2 members. Okay, you do project 1, I'll do project 2. No, it's not going to work because this amount of work for project number 2 is not enough for you alone to finish it on your own. Okay, this is the issue. Okay, especially if you are not a good student. Okay, if you are a good student, I don't mind. I think you can work on it. But if you are a bad student, homework tak pernah hantar, okay, test 1 pun tak lulus, nak buat sendiri. Kirim salam lah jawabnya. Okay, it happens, it happens. And so please remember, this is a 2-member group project. Okay, there are issues. There are issues. One issue is that, like what I said just now, only one of you do the project. So project 1 is assigned to first member. Project 2 is assigned to the second member. No, this one doesn't work. Okay, that's one problem. The other problem is, okay, you sign up for, let's say, group Alpha. You put your name in group Alpha, but you never show up. Bila kita message, when the first member message you, you keep quiet. You are not doing anything. It is better in this case for you not to register at all. Okay, not to be involved in. I know there is a student. Okay, that student never submitted anything, never submitted any homework, never submitted any answer for test 1. And yet, he registered he joined a group. I don't know what is his intention. I don't know what is his intention. Maybe dia nakkan free right from the other team member, which is not correct. Which is not correct. So, don't think he's here anyway. Let me this session right now. Let me see. Okay, I don't think. Okay, let me scroll the name here. Nope, he's not here. Okay, so I don't think he's interested. I don't think he's interested in doing the project. So I think one student complained to me about this. So for the one who complained, just do not include your team member's name yang tak adil. So this is very bad lah. This is very bad. Okay, so let's look at the project again. Again, it is a 2-member. If you try to do it on your own, I think it will not work. It will not work. Okay, it will not work. Okay, especially if you are not a good student. Especially if you are not a good student. So, okay, so this is the problem. This is about a bound and pitch. So when your car is moving along a rough road, so your car can bounce. Bouncing mean in the Z direction, vertical direction. But in this paper, in this question, your vertical direction is mentioned as X. And then you also have what we call pitch, which is forward and backward motion, rotational, and this is called pitch. So this is for basically try to find what is the best. You can do this to find what is the best KF for suspension system. But in this case, it's not about the suspension system, but in this case, it's trying to find the two things here, x, which is the bounce, and the pitch, which is, in this case, theta here. Theta and x. These are the two unknowns that you need to solve. Okay, you need to solve. And the equation is this one. The equation is this one. And you see that this is an ODE. This is an ODE. Note that this is x double dot, which means this is x double dot is just d square x dt square. Okay, so this is second derivative. This is first, this is x, and this is theta. And note that for the pitch equation, this is d square theta over dt square. So this is second order or second derivative of theta, and then x and theta. Note, equation has x and theta, which means this one need to be solved simultaneously. Okay, you cannot solve individually. Note that this is a two unknowns with two equations. So you need to solve this system of ODE. Okay, system of ODE. So this is a system of second order ODE. Okay, so you need to solve this, and I think I mentioned this: Euler's method, Hewitt's method, and classical fourth order Rangka Kata method RK4. Note that I want octave, and that's one group at least. Okay, send it to me using MATLAB. Saya dah bagi tahu jangan guna MATLAB sebab saya tak ada MATLAB. Okay, please use octave. Do not use MATLAB. Okay, I do not have MATLAB to run your code. Okay, so please use octave. Okay, ada satu group tu dah hantar lambat. Hantar MATLAB pula. Saya tak tahu nak cakap macam mana lagi. Okay, dia tak baca langsung kita soalan katnya. Which is very frustrating. I want to help you, but you are not helping yourself. So, kalau fail jangan salahkan saya lah. Kalau fail jangan salahkan saya, because I try my best to help you, but you are not helping yourself. So, that's it lah. Saya tak boleh nak bantu dah. Tak sudi dibantu katnya. Alright, so this is the thing. This is the thing. So, use octave. Please use octave. The latest octave version is 7.1.0. 7.1.0. And it is free. It is free to download. 7.1.0. So use octave, and this is what I want. Okay, right. One script. One script saja. Only one. Ada group hantar sampai 5 M file. Saya kata saya minta satu saja. Saya minta satu. I know you are calling functions. Buat function within that script. Do not panggil external files. So that's why dalam kali ini saya tulis dengan jelas, without any external function files. Okay, so maybe my English is bad in such a way kamu tak faham apa saya nak. Okay, so please follow instruction. Benda ni saya bagi bukan 2-3 hari, saya bagi 3 minggu untuk diselesaikan. Okay, ada group hantar sampai 5 M file. Lepas tu komplain tak boleh nak submit. Memanglah tak boleh nak submit. The system is set to accept only one PDF and one M file. Okay, so macam mana? Saya pun tak tahu mana satu main file dia. Isunya. I just want one file. If you can do external function call, you can also do internal function call. Tak ada masalah. Okay, but I want you to have only one file for my convenience. For my convenience. It's not for your convenience. Saya dah terang kat sini only one octave. In project 1 I say an octave file. An octave. An mean one. Okay. Okay. Use Euler method, Hewitt's method, and classical fourth order method to solve equation 1 and pseudocode. I think in the first project, I gave you the theta and bounce for h equal to 0.001 from 0 to 10 seconds. This is a lot of numbers here. How many iteration? 10 bagi dengan 0.01. Apa? 10,000 Okay. Now, okay, so then you get this lah. You get this. And the second one, tabulate. tabulate mean put it in the form, table form. Okay, in the table form, tabulate pitch and bounce as a function of time with h equal to 0.5. Okay, for 0 to 10. So in this case, 0 to 10. So this is the table. So the table, so for Euler's bounce, this one, Hewan's method punya bounce is this, RK4 bounce is this. And this one is the pitch, which is in radian, in radian. So 0 to 10 with a h of 0.5. So, and then it says determine the maximum pitch and bounce and the time up to 3 decimal places at which they occur. For example, dalam case ini, it shows that the Euler maximum bounce is, what is the bounce? At t equal to what time? Note that you tabulate only up to 1 decimal place. But what I want here, t is up to 3 decimal places. 3 decimal places. So the value and the time might not be in your table, but it must be somewhere that you keep. Okay, the same thing for Ralston. No, sorry, this is not Ralston. This should be Hewan's. Sorry, this is Hewan. There's a typo here. This should be Hewan and Hewan's. Okay, Hewan's. Hewan's and Hewan's. Okay, so that is part B. And then part C, plot graph of pitch and bounce as a function of time with h equal to 0.1, 0.01 for t, and for the all 3 method. Sample, sample. Yang this one, because I do not have time to draw for all 3, but I draw for only Euler and Ralston. But in your case, you need to show all 3. Euler, Hewan's, and RK4. Okay, all 3. So the whole idea is to see the accuracy of all the 3 methods. So you can see that in the case of Euler and Ralston, initially they are okay, but when t is increasing, you can see that now there are some differences. The same thing for bounce. The same thing for bounce. You can see that from the plot, the maximum bounce is about, I don't know, maybe this value here for Euler and this value here for Ralston. Okay, so this is the idea. This is the idea. Okay, so these are the 3 that I want. Okay, so you need to use these 3 methods, and these are the pseudocode, which means the code must be in your script. Okay. All right, so Euler, RK, and then of course these are just the standard expectation is that the understanding of how to solve second order ODE. Second order ODE. But so far we only learn what is the first order ODE, numerical, using numerical methods. Determining the accuracy of the 3 methods used in this project. Of course, for the case of Euler and Hewan's and RK4, you know there are, all these 3 are of different orders. First order, second order, and fourth order. So I think you should know which one produces the most accurate result in this case. Okay, so these are the standard octave scripting. Again, let me stress octave, octave, and octave, not MATLAB. Please, not MATLAB. Okay, octave scripting that includes all basic programming commands such as input, output, process, selection. There are some students who using copy paste. If you have to repeat 10 times, you copy paste 10 times. This is wrong. This is wrong. This is not an efficient way of programming. I think you learn this in your 1013. Use loop, for loop, or while loop, or whatever loop. Okay, it's up to you. Okay, it's up to you. So you need to show me that you really understand. There are 5 basic instruction in programming. So input, output, process, selection, and loop. Okay, you need to show me the loop that you use. Okay, and then of course technical report writing. Okay, this is the project submission. This is standard, the same one as project number 1. The same one as project number 1. And again, I want to stress that do not use fancy font for your signature. As saya tak accept, I do not accept that. Okay, scan. Use a scan one. Okay, of course saya akan tengok panggil randomly pick group I'm in the process of picking random group untuk project number 1 project number 1. Saya nak tanyalah apa yang dibuat, dekat mana, apa dekat mana dia punya, for example, where is the forward elimination punya code dalam program tu. All this kind of thing lah. Now, okay, again fully commented source code. The script subcopy must be submitted together. Okay, you must submit script soft copy because I want to run it. And if you submit soft copy of MATLAB, then it might not run on my Octave. Okay, and the report soft copy. So this one is in .m format, and this one is your PDF. No mark will be given if the script soft copy is not submitted because I cannot verify your program. So I need that program. Okay, this thing every semester akan ada yang tak hantar. Every semester adalah 1-2 group nanti yang tak hantar dengan dia punya not submitting the code the source code. The alasan is macam-macam. Okay, kamu, I don't know lah. I've been teaching this class for a lot of years. You took this class maybe this is your first time or maybe this is your second time. So I heard a lot of excuses, a lot of same excuses. Doktor, saya punya file corrupt, doktor. Saya punya hard disk rosak, doktor. Saya baru balik pada kelas komputer, betulkan komputer, doktor. Macam-macam. All this alasan all these excuses is not new to me. Okay, it's not new. I heard this a lot of times. A lot of times. So please do not make excuses. I train you to be a good engineer. I do not train you to make excuses. Okay, please do that. Okay, please do the project. Do not try to make excuses. Okay, and include this following statement, which is the standard statement here. And of course, I gave you the rubric for you to get good grades for this project. Okay, this is what I want. This is what I want. Okay, for example, I mentioned just now programming. Okay, for example, this one. Programs run and give all required output successfully and use all basic commands. Okay, all basic commands such as loop, if, then, else, and so on. Okay, these are the things. So all these are given points to you. Given points to you. So you might get 4, you might get 5, you might get 3.2 or so on. Okay, so these are the rubric. These are the rubric. So when you work on your project, please take a look at the rubric first. So it will help you to write a better report. It help you to write a better report. Okay, so this is the project. Please do not wait until the last minute to submit or to do. Okay, bila besok nak hantar, malam ni baru nak mula, and then besok pagi contact saya, doktor, komputer saya rosak. Aduh, ini dah selalu berlaku untuk saya. So memang alasan yang saya dah biasa dengar lah. Saya tak boleh terima alasan-alasan macam tu lagi. Very common. Okay, very common. So please, saya kata tadi, I train you to be a good engineer. I'm not training you to be someone who good with creating excuses. No, it's not that. Right? So these are the project. So basically the same. Basically the same template I used before for project number 1, except the problem now. I think project 1 is about system of linear equations, and this one is ODE, second order ODE, which is the topic that we are currently discussing. All right. So any question about the? Okay. So let me correct the this one, the typo here, and I will post edited version on our e-learning portal. But I think this is you should know that. Again, this is Yuwen's. Okay, so I'll change that later and repost the corrected version. Okay, so that is our project. So now what I'm going to do here is Okay, so due date is on 3rd of July. 3rd of July before 5 p.m. Before 5 p.m. Ini selalu pun berlaku ni. Saya kata 5 p.m. Ada lagi pelajar yang 5:30 baru contact. Doktor, tadi internet saya bermasalah. Tapi bila saya check log record dia, pukul 5 tu, pukul 4.55 tu dia log in kat sistem. Tapi dia kata internet dia bermasalah. Saya pun tak faham macam mana internet dia bermasalah. Tapi log record dia menunjukkan dia masuk dalam e-learning masa yang dikatakan bermasalah tu. So again, saya kata janganlah make excuses. Janganlah make excuses. Alright, so that's it for the project. So what we want to do here is today, what we are going to do is to talk about this one. Second order ODE. Before we can talk second order ODE, what I want to do is to talk about system of ODE. Okay, so our project is a system of ODE. System of ODE. So 1 and 2 because both has the unknown here. So x and theta. X and theta. So equation number 1 has x in it. Equation number 2 also has x in it. Okay, equation number 1 has theta in it. Equation number 2 has theta in it too. So basically, there are two unknowns in both of the equations. So there are two unknowns with two equations. We must solve it. We must solve this simultaneously. Okay, that's one thing. That is a system of ODE. And the other thing is this is a second order ODE. So your project is basically about second order ODE, second order system of ODE. Okay. So what I'm going to talk today is, first of all, I need to talk about system of ODE first, before we can go to the system of second order ODE. Okay, so let's say I have these two equations. This is from your textbook. Textbook example. Okay, this is from your textbook, which is example 25.9. 25.9. Okay, example 25.9. Example 25.9, and the question is dy1 over dx is equal to minus 0.5 y1. Okay, this is one equation. And dy2 dx equal to 4 minus 0.3 y2 minus 0.1 y simultaneously, because we cannot solve this individually because there are two unknowns here. There are y1 here and there are y2. A system of first order ODE, because the derivative here is to the order of 1, the first derivative. So this is the ODE or the first order. Okay, so we cannot solve this because in order to solve for y2, we need y1. Okay, we need y1. So we need to solve this simultaneously. Okay, so we know how to solve first order ODE, right? First order ODE, we know how to solve it. First order ODE, okay, it can be the simplest one is Euler's method. Second one is either Hewan's midpoint, Ralston, which is part of RK2, and of course, then we have RK method, RK1, RK2, RK3, RK4, and so on. So let's say this is RK4. Okay, so we know how to solve one first order ODE. But in this case, we have two first order ODE. So how do we solve this? So the way to solve this is just to solve this simultaneously, for each of the in this case, because we have two first order ODE, so we must have two initial conditions. And the initial conditions are, okay, y naught at x equal to 0, y1, y1 is equal to 4, and y2 at sorry, not y2, sorry, not y2, this is wrong. Y1 at 0.5 equal to 3, equal to 3. Okay, so this is the boundary conditions. Note that we have two ODE, two first order ODE, which requires two initial condition to solve. Okay, two initial condition to solve. So this is the problem here. This is the problem. So we can easily solve the first equation if we know only the only this, right? Because for the first equation, we do not have to know what is y2. But in order to solve for y2, then we have to solve this simultaneously. So from the first equation, we know that y1. So let's do this using Euler's method. So let's try to use Euler's method. A simple one, Euler's method. And I think the requirement is that our h from the example is 0.5. 0.5. H is h or delta x, which is equal to h equal to 0.5. This is what we want. So from the first equation, we know that this is just y1 I plus 1, the first iteration, the index equal to y1 I minus, minus 0.5 y1 I. Okay, this is from the first equation. And from the second equation, you can see that this is y2. Oh, sorry. This one must have delta x, or this is times h. Okay, so this one is I plus 1 equal to y2 I, and then plus 4 minus, let me have a bracket here. Okay, maybe for this one, let me write more details so you can see what is happening here. So in this case, it is just from the second one. From the second one, you know that this is just y2 I plus 1 minus y2 equal to 4 minus 0.3 y2 minus 0.1 y1. Okay, or if we simplify this, I plus 1 minus yi, I equal to 4 minus 0.3 y2 minus 0.1 y1 times h. Or the final version, the final form of this equation is just yi plus 1 equal to y2. Sorry, this is y2. y2i, y2i plus 4 minus 0.3 y1, y2 okay, y2i, oops, y2i okay, y2i minus 0.1 y I times h. Okay, so these are the two equations that we need to solve this simultaneously. Simultaneously. So, okay, now look at initial conditions. We know that our initial condition just now, which is our y10 is equal to 4, and our y prime, y1 at 0.5, which is equal to y1 at okay. No, I think let's forget about this first. Let's forget about this first. Because I want to write this the equation now. So first iteration. First iteration. So let's start with first iteration. First iteration. We have our first iteration from this one. It is just let's make this smaller so you can see that y1 first iteration, which is I equal to not first iteration. Initial iteration. Sorry, initial. Let me say initial. I think I'm looking for the better term here. Okay, so initial iteration. So y1 I equal to 0. In this case, I equal to 0. So y1 equal to y10 minus 0.5 y10 times h. So y10 is equal to 4. Okay, iteration I equal to 0 and x equal to 0 lah. X equal to 0. So now this is equal to 4 minus 0.5 times 4 times h. H is 0.5. 0.5. So this is equal to 3. Okay, equal to 3. So y1 1 is equal to 1. And then from the second equation, y2 1 equal to y20 plus 4 minus 0.3 y20 minus 0.1 y10 times h. So what is y20? No wonder I get it incorrect. Sorry, my boundary condition should be if you look at your textbook, I make a mistake here. So this should be y20 is equal to 6. Okay, equal to 6. So this one is y. Okay, we know that y20 is equal to 6. Now we can solve for y2 equal to, okay, if you do this correctly, you get this one equal to 6.9. 6.9. Okay, so this is the initial iteration. And now next, the first iteration, I equal to 1. Sorry, this is first iteration. Sorry, I keep getting this incorrect. So if you do this Okay, first iteration. First iteration. Answer for first iteration. First iteration. Okay, you got this. So you get y1. You get your y1, the first iteration, y2, first iteration, which is this number. So you can get the table here. So you get your x0, y1, and y2. So this is 4 and 6. These are the initial condition. And when x is equal to 0.5, this is 3 and 6.9. Sorry, 6.9. And again, I have to repeat this for one more cycle. So in this question, it asks for you to integrate to step x equal to 2. So we need to do 0, 0.5, 1, 1.5, and 2. So I think I have this in Excel. So let's do this. Let's do this using Excel. Let me share my Excel with you here. So this is Excel. So I hope you can see my Excel. Okay. So let me make this bigger so you can see. Oops, this is too big. Okay, so these are the equations. These are the equations. So, so this is my y general formula. So my iteration 0 is basically your initial condition because x0, y1 is 4, y2 is 6. This is given in the problem. And your h or delta x is just 0.5. So for the first iteration, x equal to 0.5 is just y1 is this value, which is equal to y naught. Y naught is y1 naught, which is this value, minus 0.5 times y1 naught, which is this, times this, times h, which is this value here. And let me put dollar and dollar here, dollar and dollar. Okay, so which is 3. Okay, just like we calculated just now. And for y2, which is this one here, this formula here. So y2 is equal to y2 naught, which is this one, plus 4 minus 0.3 times y2 naught, which is this one, minus 0.1 times y1, which is y1 naught, this one, and everything times by this h, which is 0.5. Okay, so 6.9. So this is what I got just now, right? So again, with Excel, this become easy because we can just copy. Can just copy. Okay, this is the same answer as in the textbook. Okay, so you can just copy this. So this is the solution. This is the solution. So basically what we have done here is we solve two first order ODE simultaneously. That's it. We just have two ODE here, two first order ODE, this one and this one here. Okay, and we solve it simultaneously. So we solve it at y1 and y2 simultaneously. So this is the initial conditions. Yeah, this is the initial conditions. When x0, y1 is equal to 4, this one. When x0, y2 is equal to 6, which is this one. Okay, so initial condition is at x equal to 0, and your h is 0.5, which is delta x. X1 minus x0 is 0.5. So this one minus this one is 0.5. This one minus this one is 0.5. All right, so this is the system of ODE, right? Straightforward. Now, let's go to one more, which is this one here. Okay, which is this one. So let's look at second order ODE, the one which is the one which is similar to your project. Second order ODE. So second order ODE. Okay, by the way, there's a video on this. You can watch my video. I think I've had the video on e-learning, but for the example of second order ODE, I think I misassigned. The sign is wrong. It should be a negative number, but I put positive number. So the result might be incorrect, but the method is okay. So let's say I have this problem, second order ODE. Okay, by the way, for our problem here, so I'll solve this using Euler's method. Of course, you can also use Hewen's method or RK4 method if you want. And second order ODE, let me look at the example in your textbook. This is page problem 25.3. Problem 25.3. This is problem 25.3 in your textbook. So the equation is d square y dt square 0. So definitely this is a second order ODE, right? Why? Because of the highest derivative in this question is second order, second derivative. So this is a second order ODE. But we have the other thing is that, but we know that we can solve two equations simultaneously, two first order ODE simultaneously. But can we use that approach to solve for this, to solve for second order ODE? Okay, note that this is a second order ODE. This is a second order ODE which requires two conditions. Okay, two initial conditions in this case. Two initial conditions. So what are the two initial conditions in this problem? It says that at t equal to 0, okay, initial condition. Okay, at t equal to 0, y0 equal to 2, and dy dt at t equal to 0 equal to 0. Okay, this is the boundary conditions. So this is just like our simultaneous ODE. It has two boundary conditions. It has two initial conditions and two first order ODE. So the only difference here that we have two initial conditions, but we only have one second order ODE. So the plan here is to convert one second order ODE to become two first order ODE. Okay, because we know how to solve two first order ODE. This one, we know how to solve this. Okay, we know how to solve this. So let's reduce this order here. It is a first order, right? This is a second order. So we need to reduce that to first order. So the idea here is to introduce a variable. So let me introduce, let's say, let, okay, so that, where is my solution here? Okay, so let z equal to dy dt. Okay, let z equal to dy dt. Then we know that d square y dt square is just d dt of dy dt, right? So these two terms are the same because this is d square, so we have d and d, dt square, we have dt times dt. So this is the same. So basically this is just d dt of z, right? Of z, because dy dt is equal to z. So now we introduce this new equation. So let's substitute that to this equation here. Okay, so that then substitute, we know that now d square y over dt square minus t plus y equal to 0 is just d square y dt square is just dz dt. dz dt minus equal to t minus y. So this is our equation. Note that this is only first order. So this is our equation and this is another equation. So in this case, this is our first equation. This is our second equation. Look, now what we have here is two first order ODE. Can we solve two first order ODE with two initial conditions? Yes, we can do that because we did that before at this case here. Okay, so let me rewrite this. Okay, so let me delete this first. Okay, or we can say that this is just dy dt. Okay, dy dt equal to z. So this is our first equation. Okay, so okay, I don't know what happened here. You won't let me write. So we can say is from 1. We know that this is just y I plus 1 minus y I equal to yi plus z times h. And h in this question is 0.1. So h is 0.1. Okay, so we can solve that. And then from 2, we can solve this is just z I plus 1 equal to zi, okay, plus t minus ti ti yi times h. Okay, these are the two equations that we need to solve simultaneously. Okay, we need to solve simultaneously. So our first iteration, we can see that y1 equal to y0 plus z, and this is z1, z1, sorry, not z1, zi. So z0 plus h. So what is y0? Let's look at the initial condition. So y0 is equal to 2. y0 equal to 2. what is Z naught? Z naught is dy dt, right? Dy dt is our Z. So this is actually Z naught equal to 0. So Z naught equal to 0 times 0.1, which is y1 equal to 2. And how about Z now? Z1 equal to Z naught plus T1, T naught minus Y naught times H. So Z naught is 0, right? Z naught is 0, initial condition. Z naught is 0 plus T naught is 0 minus Y naught. Y naught is 2 times H. H is 0.5. So this one, let me double check. Let me double check. Okay, let's look at my Excel here. So my Excel here, okay, is okay. So this is the first. Okay, so now, oh, I don't have the solution here. Oh, okay, I think I have the solution here. So minus 4. So let me copy this. Let me copy this and put it back here. Okay, so this is my solution here. This is my solution. Okay, this is my solution. Okay, so it's 2. Okay, y1 is equal to 2. And this one is 0.1. This is minus 0.2. Is this correct? Yeah, minus 0.2. Okay, this is just Z. Z is just this value here. This value here, Z. Z prime is our dz dt. So dz dt is just this value here. Dz dt is this value. T0 minus y naught. Y naught is, in this case, dz dt. T is 0, y naught is 2, so it's minus 2. Okay, so you can do the same thing. So what we want here is y1 and z1. So now what we have done here is basically converting a second order ODE to become 2 first order ODE, because we know how to solve our set of or system of first order ODE, right? So that's the approach here. Okay, I think I'll give you an assignment for you to familiarize yourself with this ODE. Note, this is the approach that you might want to use for your project number 2. Okay, for your project number 2. Because in your project number 2, it's a second order ODE. It's a second order ODE, a system of second order ODE. Okay, so I think that's it. I think I took your time. It's already 1 p.m. So let's stop here now. And thank you everyone. Yeah, thank you everyone.